Right now, inside every federal courthouse, every intelligence agency office, every classified military facility in the United States, and across the United Kingdom, there is a material lining the walls, the ceilings, and the floors. A material so effective at blocking wireless signals that not a single Wi-Fi packet, not a single Bluetooth ping, not a single cellular whisper can pass through it. And that material costs less than $2 per square foot at your local hardware store. The telecom industry has known about this for decades. And for decades, they have made absolutely certain you never thought to use it yourself. The wireless industry pulls in over $400 billion globally every single year. Every router upgrade, every mesh network system, every signal booster, every so-called dead zone solution they sell you, all of it depends on one thing, that you never discover how easy it is to control, redirect, and completely block radio frequency signals on your own terms. Because the moment you understand what RF shielding actually is, the moment you realize that a simple, inexpensive metal sheet does what a $300 signal booster claims it cannot, their entire business model starts to crack. Entire product categories collapse. You stop being a customer and start being someone who actually understands how electromagnetic fields behave. They have spent millions in marketing and product development making sure that never happens to you. But that changes today. By the end of what you're about to hear, you will understand precisely which metal, precisely which form, and precisely which method turns a $2 sheet into a professional-grade Faraday barrier. The same technology used in government SCIFs, hospital MRI suites, and military command centers. You will know exactly how to source it, exactly how to apply it, and exactly what mistakes will render it completely useless. And I will also show you the one unexpected consequence of using this material that almost no one in the DIY community ever warns you about. Stay with me, because it is not what you think. To understand why this was never talked about openly, you have to go back further than most people realize. The science behind electromagnetic shielding was not invented by a government lab or a defense contractor. It was demonstrated publicly in 1836 by a British scientist named Michael Faraday, who showed the world that a conductive metal enclosure could completely block external electric fields. He called it an electrostatic screen. History calls it the Faraday cage. The principle was simple, documented, reproducible, and freely available in scientific literature for over a century before wireless communications even became a consumer product. When radio technology first became commercially widespread in the early 20th century, engineers already knew exactly how to contain and block these signals. The knowledge was not hidden, it was simply never given to you. As wireless communications moved from military and government use into the consumer market after the Second World War, and especially as cellular networks and then Wi-Fi infrastructure became the foundation of trillion-dollar industries in the 1990s and 2000s, there was an invisible but deliberate shift in how this information was framed. RF shielding was repositioned as a highly specialized, highly technical, enormously expensive industrial application, something requiring certified engineers, laboratory-grade materials, and professional installation. The telecom industry did not suppress the science. They suppressed your belief that you could ever use it yourself. And for 30 years, it worked. What I am about to show you is the part the industry spent decades making sure you would never find out. Because once you see the actual material and understand why it works at a molecular level, the mystique disappears. And so does every reason to spend money on their solutions. The material is aluminum foil, not the thin domestic cooking variety, though even that has measurable shielding properties. The specific form is heavy-duty aluminum sheet, also sold as aluminum flashing tape, aluminum foil insulation board, or aluminum-faced building wrap, all of which are available at hardware chains for between $1 and $3 per square foot. And the reason it works is not complicated. Wi-Fi operates on radio frequencies, primarily 2.4 gigahertz and 5 gigahertz. These are electromagnetic waves. When an electromagnetic wave strikes a conductive surface, any surface where electrons can move freely, those electrons immediately redistribute themselves to counteract the incoming field. The energy does not pass through. It is either reflected back or absorbed and dissipated as a negligible amount of heat. Aluminum is one of the most efficient conductors on Earth. It is lightweight, it is non-toxic, it does not corrode in normal conditions, and it is extraordinarily inexpensive. It is, in every measurable way, the optimal material for blocking Wi-Fi signals. A single layer of heavy-duty aluminum, with no gaps, no seams, and no penetrations, will attenuate a standard Wi-Fi signal by between 50 and 100 decibels. To put that into perspective, a 50 decibel reduction means the signal on the other side is 100,000 times weaker than it was before it hit the barrier. At 85 to 100 decibels of attenuation, the signal is, for all practical purposes, gone. If you have followed this far and you want to keep receiving this kind of knowledge, the kind that does not appear in product manuals or sponsored content, join the people who already have. Most of what you are about to learn was sitting in plain sight for over a century. Now here is exactly how you do this correctly, because there are several critical mistakes that will cost you the entire effect. First, identify your application. The two most common uses are blocking Wi-Fi from entering a specific room for privacy or security purposes, or creating a dead zone around a particular device or area. For a room, you will be lining walls and potentially the ceiling and floor. For a smaller application, a box, a cabinet, a drawer, the process is identical but smaller in scale. Second, source the correct material. You want aluminum foil tape, the type used in HVAC duct sealing, or aluminum-faced foam insulation board. Both are available at Home Depot, Lowe's, B&Q, and most regional hardware stores. Do not use standard kitchen foil for large applications. Its thickness is insufficient, and it tears at seams. The foil tape comes in rolls, typically 2 to 4 inches wide, and is pressure sensitive on one side. Third, and this is the mistake that destroys most DIY shielding attempts, every seam must overlap by a minimum of 2 inches and must make electrical contact. The aluminum must touch aluminum, not just be adjacent to it. A gap of even a few millimeters in a seam is enough for a signal to pass through. When you apply strips of tape to a wall, each strip must overlap the previous one, and you must press the seams firmly to ensure conductive contact across the entire surface. Fourth, every penetration is a vulnerability. Any hole, a pipe, a wire conduit, an electrical outlet, is a potential signal pathway. For outlets, you can purchase aluminum-backed outlet gaskets. For pipes and conduits, you wrap the foil tape around the penetration point, forming a collar that maintains contact with the wall surface. Fifth, once your surface is covered, test it. Use a smartphone's Wi-Fi signal meter or a free RF signal app. Stand inside the shielded space and check the signal strength of networks that were previously visible. A properly sealed room will show 0 detectable networks. If signals remain, scan the walls carefully. You're looking for an unsealed seam or missed penetration. Before wrapping this up, there is one more thing about this solution that almost nobody talks about, and it is something that will either make you reconsider your approach or make you far more deliberate about where you apply it. A properly shielded room does not just block incoming Wi-Fi signals, it blocks all wireless transmission in and out. That means cellular calls cannot enter or leave. Emergency calls, including 911 and 999, will not connect from inside a fully shielded space. This is not a flaw in the method. It is the method working exactly as intended. Government SCIFs are designed precisely this way, but for a home application, this is a critical consideration. Most people who use this technique apply it selectively. A home office for data security, a bedroom for reducing wireless exposure, a server room for containing signals within a perimeter. Full room shielding for a living space requires a clear plan for emergency communication access. Now consider what this actually means in practical terms. Before this method, a router showing 6 or 7 networks in a standard apartment building, a bedroom where 3 different Wi-Fi signals were measurable at full strength through 2 walls, a home office where neighbors and their devices could see your network name. After this method, 0 detectable external signals. None. And the cost breakdown is this. Covering the 4 walls of a standard 12 by 12 foot room requires approximately 140 square feet of aluminum foil tape. At an average retail price of between 30 and 60 cents per square foot in roll form, the total material cost for a room is between $40 and $85. Professional RF shielding installation for the same room, sourced through a certified contractor using the same underlying technology wrapped in a commercial product name, costs between $1,200 and $6,000. The material doing the work is functionally identical. What you are paying for in the professional version is the brand, the certification documentation, and the assumption that you would never look this up yourself. The solution you have just heard about is complete, it is effective, and it is available to anyone willing to spend an afternoon and less than $100. But here is what most people do not realize until after they have done it. Once you understand how electromagnetic fields are controlled with a simple conductive surface, once you understand that the same principle applies to cellular signals, to Bluetooth, to GPS, to RFID, you begin to understand that the wireless world around you is far more manipulable than you were ever led to believe. And that raises a much larger question. If a $2 material can block the signals your router broadcasts, what else is being broadcast through your walls that a $2 solution could stop? The answer to that question involves a different kind of frequency, a different kind of exposure, and a different industry that has been even less forthcoming than the telecom sector. That story is for the next time.